Okay, so that brings us to a new problem and a new class. Here we need to write a class that represents a vector. So remember that a geometrical vector, I got such awesome drawing here, let me just use it. Remember that a geometrical vector is like it's like a guy that's characterized by the endpoints, right? So it's a vector like you saw it in mathematics, and we're just going to consider 2D vectors here. So it's basically just a class that stores the two endpoints. Then we can do various operations to this vector, so we can scale it. So we can maybe say 3 times v, and that's going to scale these coordinates by 3. Hopefully these are concepts that you've seen in linear algebra. You can also add vectors together. So if you have another vector w, you can v plus w. So here we have another vector. Then you just add the x coordinates together, and you add the y coordinates together. Anyway, that's what we want to build towards, something that can represent these kinds of operations. But we'll start a little bit slowly with the first problem here. So in the first problem, we just need to write a vector class, and the vector class needs to have an x and a y coordinate, and that's basically it. So we can maybe let ourselves be inspired by the rectangle class and observe that this is actually a simplified version of the first rectangle class. Like the first rectangle we wrote, this one up here, it's very analogous, right? It has a width and a height that's kind of like the x and the y. It's called something a little bit different, but that's basically it. I mean, so maybe we can just take our little rectangle example here and use that. You can copy paste it, but I'm going to type it in from the ground up and adapt it on the fly. I think that'll be a little more pedagogical than just doing this magical thing with copy pasting code. So here's the file where we need to write the vector class in. So we started by writing vector, class vector, we give it this name, and then we need to eventually, let's just do something like have a focus line here. We want to be able to define vectors by giving the x and y coordinates explicitly to the vector like this. Like that was what the example showed us, right? We want to just be able to pass the x coordinate, x and y coordinate directly. So in order to do that, we do the typical trick where we write this, implement this special init function. First input argument is always self, and then it's the two coordinates, exactly equivalent to the rectangle example. In this case, I'm going to call them x and y because, like before, it was width and height, but x and y is more vector-like. And then I'm going to say that store the first one as x and store the second one as y, and that's actually going to take care of it. Then I can print them out like this, and this should actually do the trick. And it's halted because I still have my figure open from the previous exercise, and that's why I need to close that before it continues. But we see that it prints out, it assigns x to 2 and y to 4, and that's why it prints out 2 and 4 here. So that would be how you adapt the rectangle example to behave like a vector. It's a little bit maybe too reductive. I think it's a really good warm-up, because in the next problems we'll see how we implement some more interesting methods in this vector class. So that's actually all I have to say about that.